Hello everyone, this is Malish from BBC Engineering College, Associate Professor CSC Department. Now this session I want to explain about the quicksort mechanism to sort unsorted list of elements made in sorted order. So first of all we understand about sorting. Sorting is one of the important computer application in our data structure to arrange unsorted list of elements made in sorted order. I have so many sorting techniques like bubble sort, math sort, quick sort, heap sort, radix sort, cell sort, selection sort. So many sorting techniques is there. But quick sort is one of the elegant sorting technique to unsorted list of elements make it in sorted order. It will be working on divide and conquer strategy. Means that if the problem is large, we can divide the problem into two subproblems and solve the subproblems. The elements are make it in sorted order. It is one of the elegant sorting technique to arrange the elements make it in sorted order. So how to sort these elements and how to divide this problem in our quick sort by choosing of pivot element selection. The most of the developers taking the starting element of in our unsorted list of elements is taken the pivot element selection, and we have to take two more considerations, that is low consideration and high consideration. The low consideration is taken as the starting index of our array element and high is taken as the last index of our array element. Right, let us see the example how to sort these elements by applying quicksort mechanism. See this example. In this we have to take the low consideration and high consideration and pivot element selection like this. So after that we are taking some four conditions, that is pivot element is compared to a of I index positions and the pivot element is compared to a of low index positions. Right, first we have to change the comparison. First 50, the pivot element is compared to a of I index position, that is 50 less than 20, the condition is not true. So once the condition is not true, we can swap this element C in step 2. That's right, C in step 1. So the pivot element is compared to low index positions, that is 50 greater than 20, condition is true. We can increment low position from 0 index to first index C in step 2 like this. So once this condition is false, we can repeat the statement. Again, the pivot element is greater than 30, the condition is true, we can increment low position. So same fashion we can observe these points. In step 4, that is pivot element compared to A of low positions, that is greater than 90, the condition is not true. So we swap these elements like this. See in step 5 that elements are swapped. So again, once the elements are swapped, we can change the comparison, means that the pivot element is compared to A of high positions, that is 50 less than 90, the condition is true. So once this condition is true, we can decrement high position from 5th index to 4th index. See in step 6 like this. So coming to the step 7, again the same process is applied until the condition is false, right? The pivot element is 50 and A of I means A of 4 index, that is 80, 50 less than 80. The condition is true. Once again we can decrement the high position. So see in step 7. So once you observe that the pivot, low and high positions are placed in only one place, that is called the problem is divided. So you can observe that the left sublist elements is smaller than the pivot and the right sublist elements is greater than the pivot element. So we are taking the left sublist 20, 30, 10. So again the same process is applied. The low is the 0 index and 2 is the high index and the pivot element is 20. Again the same process is applied. The left sublist elements are sorted order like this. So now we are taking the right sublist elements, that is 80, 90. They're taking the low, high and pivot element selection. The low is the 4th index and high is the 5th index and pivot element is the 80 element. Again the same process is applied. The right sublist elements are made in sorted order. So finally we observe that the total array list of elements made in sorted order. So this is the quicksort mechanism. So let you see this example on this algorithm is whatever the procedure I am discussing, the same we can discuss here. So here partitioning algorithm is used to divide the problem into subproblems with pivot, and the elements of left sublist elements and right sublist elements are make it in sorted order. We can arrange this partitioning algorithm. So let we coming to the complexity. We have best case, average case, and worst case time complexity. The best case it will be taken as big O of n log n, and average case it is also a big O of n log n, and the worst case it will taken as the big O of n square is the time complexity. So right, it is the most important complexities by using in our quicksort mechanism. Thank you.